Okay, number 13 is a fun little mess. So this is all about fractions, obviously, right? We got fractions here. You see this, I hope. Simplify that. Now, I don't know why it does this just to throw you off. I don't know what the point of x is greater than 3. X would be need to be greater than negative 2. You can't divide by 0. You can't. So there are a few constraints into this. Since you can't divide by 0, you couldn't have. It should say x does not equal minus 2 and x does not equal minus 3, right? Because there it all falls apart. But how do you add this part on the bottom? So you're just going to simplify this, because you don't want fractions on top of fractions. I mean, that looks pretty weird, right? So you want to get it to looking like something that doesn't look weird, or looks weird in a different way, you know? You don't want fractions on top of fractions, unless you're really weird and you like doing these problems. So how do you add 1 over x plus 2 plus 1 over x plus 3? Well, how do you add 1 over 3 plus 1 over 2? How do you do that? Remember, when you're adding fractions, you have to have a common denominator. So on this side, I gotta multiply this guy by 1, which takes on this, 1 can take on many forms, right? Any form you need it to do, right? That's the magic of multiplying by 1, is you can choose a strange looking 1. 2 divided by 2 is 1. Okay, and over here you can choose a different way to look at 1. Right? This is kind of the abstract way of thinking about it, I guess you'd say. But multiplying by 1 is the multiplicative identity, is the fancy way of saying it. So you got now you'd have 2 over 6 plus 3 over 6. Okay, and you'd have 5, 6. So 1/3 plus 1/2 is 5, 6. Over here, I got to get the same denominator. So I'm going to multiply this side by x plus 3 over x plus 3. That's 1. So what they're trying to see here is, if you've gone far enough in algebra that you understand, do you really understand adding fractions? So that's one part of this silliness, right? Do you really understand what it means to add fractions? To add fractions, you have to have a common denominator. Well, it doesn't matter if there's x's and y's and whatnot. You got to have that common denominator. So now I would have x plus 3 over x plus 3 times x plus times x. Let me just write it. X plus 3 times x plus 2 plus x plus 2 over x plus 3 times x plus 2. Okay. All right. Oh, and then what is division? But that's the second step. So we're simplifying this denominator here, and we're simplifying the denominators of the denominator. Okay, so now you're going to you simplify this guy. What's your next step? X plus 3 plus x plus 2 over x plus 3 plus, when you're adding fractions, you keep the denominator the same. As long as you got like denominators, then that is your denominator, right? So x plus 3 times x plus 2. And then you need to go ahead and multiply that out. X, well, I guess I'll write this step. X plus 3 times x plus 2. And then you simplify this guy. And then we'll replace that right there. So you got x plus x is, hopefully I don't run out of room, 2x plus 5 divided by x squared plus 2x plus 3x plus 6. Now, then if this, we replace this back with this mumbo jumbo, these two fractions, then when I divide 1 divided by that, it's the same as multiplying by the reciprocal, right? So then they're dividing by fractions, you multiply by the reciprocal. So 1 over this changes to x squared plus 5x plus 6 over 2x plus 5. I can give you a practice problem on that one, I suppose. Yeah, I mean anything. How about 1, what would be, here's a practice problem, 1 over 2x, or 1 over x plus 1 over x plus 1. So simplify this. So all you're doing is, this is just called simplifying. You get a crazy looking fractions on fractions stuff and you need to simplify it. I mean, yeah, that still looks crazy, but it's a simplified, it's not a fraction on top of another fraction that's added, right? You have a term, not a term, you have a polynomial on the top divided by, you got that. That's how you simplify it. That's just weirdness of math. So go ahead and simplify this, and then I'll solve it at the beginning of the next little video.